We are now moving to drones. Are they going to revolutionize the future? Welcome to a discussion that promises to explore the revolutionary aspect of drones on the future of mobility and connectivity across Asia. The region is at the forefront of a transformative shift in aerial technologies, with drones and urban air mobility emerging as key players in reshaping urban living and transportation. In India, the drone industry is experiencing rapid growth, propelled by government initiatives aimed at establishing the country as a global drone hub by 2030. Liberalized policies and production-linked incentives have attracted substantial investments, fostering a vibrant ecosystem with over 200 drone startups receiving significant funding in recent years. And across Asia, countries like China, Japan, Singapore, and South Korea are driving innovation in drones, leading to breakthrough technologies and a surge in drone-related startups catering to various civil applications. UAM, the urban air mobility, including electrical vertical takeoff and landing services, is gaining momentum, with companies developing air taxi shuttles and automated aircraft for intercity transportation. As drones represent a paradigm shift in aviation, introducing new modes of transportation beyond the traditional fixed-wing aircraft and helicopters, this panel aims to delve into their potential as the third revolution in aviation. We'll explore questions such as what technological innovations and trends are driving the drone industry forward. What is the current market growth and the potential for drones in Asia? And how close are we to bridging the gap between vision and reality in terms of urban air taxi services? Join us as we navigate this. The chair of this session is Anish Michael, the lead at the Center for Future Mobility. Anish, can we welcome you on stage? Please give him a big round of applause. Oh, come on, ladies and gentlemen. Thank you. Thank you. Anish leads OMI's Foundation Center for Future Mobility and specializes in urban mobility policy and technology integration. With a focus on advanced air mobility initiatives, he drives sustainable solutions and actionable insights, bridging policy research with practical implementation to ensure mobility aligns with sustainability goals. His panelists are, and if I can welcome you onto the stage as I say your name, Mark Yong, CEO and co-founder of Garuda Robotics. Please give him a big round of applause. He's a driving force behind next-gen unmanned aerial systems. With over 2 decades of experience, he's contributed significantly to the development and commercialization of ground and aerial robotics for diverse applications. We then have Aniruddha Gupte, founder and CEO of Pod Drones Limited. Aniruddha? Please give him a big round of applause. He's a seasoned entrepreneur who's led numerous successful ventures garnering prestigious accolades such as the Economic Times Power of Ideas and the Red Herring Global 100. He has 6 patents to his name, including one which is seminal in the industry. And finally, we have Ankit Mehta, who's CEO of IdeaForge. Ankit? Oh, I'm sorry. Okay, so can we invite Sunil Jha, who's coming on behalf of Ankit from IdeaForge. Okay. Thank you so much. And over to you to start the panel. Anish.
A very good afternoon, everyone. And I welcome you all to what promises to be a very exhilarating session focusing on the theme of drones. Are they revolutionizing the future? It's my pleasure to have with us a distinguished panel of innovators and technology disruptors here today, ready to explore the most transformative ideas shaping our future economies. The significance of our discussion couldn't have come at a better time as we all convene here for the Asia Economic Dialogue 2024. The Asian region is currently witnessing a remarkable revolution in aerial technologies, spearheading to what many call the drone revolution. From Singapore to Japan to South Korea to India, countries across Asia are driving innovation in drones, backed by robust research and development, investments, and even favorable policy regulations. In India, particularly, the drone industry is experiencing an exponential growth, pushed by the government initiatives aimed to establishing the nation as a global drone manufacturing hub by 2030. And there's been a surge of activities across the drone sector, and we have a lot of drone startups coming up in the space of last 4 or 5 years, catering to a wide array of defense and civil applications. The rapid expansion of the Asia's drone industry holds tremendous promise for economic advancement, particularly in sectors of manufacturing, logistics, and infrastructure maintenance, as well as defense. And keeping all the context in mind, it is quite clear and evident that Asia is on the brink of a drone dominance. Through the course of this panel, we'll be touching upon broad aspects of technology trends. We'll be also looking at the market growth and potential based on these trends and innovations, and of course, looking at the policy and regulatory aspects, and as well as the infrastructural development that needs to go into place to make this drone revolution happen. Having said that context, I will now turn to our panelists to share their opening remarks. I would start with you, Mr. Yong. Garuda Robotics has been a trailblazer in terms of development of autonomous drone technologies. Could you probably share a little more about what Garuda Robotics does and how and the innovations that they bring to the table, specifically keeping in mind the Singapore region?
And let me start by saying thank you very much, PIC and Gautam, for the kind invitation. It's my first time in India, and I'm so glad that it's in Pune at an event as prestigious and as loaded as this, with so much talent and people who are influencing the way that our world's going to be changed. I like to approach questions like this from both ends, right? So I want to start by giving you the bigger motivation before I then pivot to telling you about the things that we make and the things that we do, so that you understand also the framework through which we make decisions about where to go and how we see the world and the changes and the trends that are coming. So back in 2015, I gave a TEDx talk, and I said, we need to start thinking, and this was at the start of the drone revolution, we need to start thinking about drones as infrastructure. So not drones requiring infrastructure, not infrastructure for drones, not inspecting infrastructure with drones, but drones as infrastructure, right? Now that's a bit confusing at the time. What does this mean? So think about your phones today. You have all these equipment, tools that you take out and the human has to go manipulate them. If you're doing work, if you are a tradesman, you have a bag of equipment that you sign out from the store and then you go do something with it, and then you have all these gadgets that you use. And that's very different from your phone that's connecting to the cloud services in the back end. That just works, right? And in a nutshell, that's the difference. We want to turn drones eventually into the silent infrastructure that just gets stuff done without a person having to go there and use it as a gadget, as something that you have to go poke a few buttons. Now, that's the big vision. So what does that actually look like? Maybe one day, wind turbines, every wind turbine has its own drone with a bunch of robots, and it takes care of that inspection and maintenance and checks. Maybe you have people working in the plantations, the farmers, who after they set everything up, never have to go and tell a drone, press a button, go off and monitor the harvest, monitor the trees, get things done for me because it's part of the infrastructure. So that is the motivating idea behind everything that we do. Now, what is it that we do? So today, when we talk about nuts and bolts and concrete things, we build intelligent unmanned systems. We build drones, we build everything, we're full stack, everything from the aircraft to the payloads that sit on the aircraft and make them useful, because having something flying that doesn't actually capture data, or doesn't actually do anything in the real world, ends up not being very useful. We also build the software layer that allows you to fly multiple drones from a single pilot station. We build the connectivity. Our drones are among the first in the world to be 5G native, meaning every drone that you bought from us from the 1st of January 2023 came with two 5G radios, and you could put in maybe one SIM card from Jio and one SIM card from Airtel, so that you can fly anywhere and always have that drone connected back to a drone operation center, bringing what you see in science fiction and in the military, bringing those capabilities to commercial enterprises, to government users, and hopefully one day, even recreational and home users. So we built all of that. But I also want to talk briefly about the ecosystem building that we do, because we don't like doing things on our own. We like doing things together with other best-in-class partners, whether it's within Singapore or in other overseas jurisdictions where we go out for the first time. So we like to build partnerships. Some of the partnerships that we build include with telcos, and they include the human capital side. Kripa, early on in the previous panel, was talking about the need for deep talent. So we are the first approved drone pilot training organization in Singapore. And we are actually the longest running organization that's been focusing on professional drone pilot training for the purposes of getting a license. Every single drone in Singapore is required to carry a tracker, a GPS tracker that's connected over 4G, and it's reporting in real time its position. So the regulators, the Civil Aviation Authority of Singapore, is able to see in real time on a big dashboard where every single drone is flying at any time. Now, we can do that in Singapore, really, really small. I'm not sure how DGCA would do that even in a room this size, right? But the idea is, with more visibility and transparency, you should be able to get more things allowed from the operators. So every drone has to carry that tracker. That's a system that we built. We were actually the first in the world, first jurisdiction to have something like this rolled out back in 2019. It was supposed to have been rolled out in 2020. Unfortunately, we all know what happened. And the government said, we're not going to impose a new regulation on people at this time. And so this finally rolled out in 2022. Every single drone carries our tracker, and it's being tracked in real time. We also then actually care a lot about infrastructure, right, for drones. We are the operators of the largest drone testing site in Southeast Asia. It's just across the border. So my Malaysia office is literally 10 minutes drive from my Singapore office. And then I'm across the border in a different country. It is about 611 hectares of land that's under a special waiver from the Civil Aviation Authority of Malaysia for anyone who wants to come in and do testing. Not just of drones, but eventually we hope for air taxis as well. Imagine having to get in an aircraft that's not being properly tested. So testing infrastructure is going to be, I think, the big gap that needs to be solved. Where will you safely fly and certify and demonstrate your equipment? It can't be at an operational airport, because that is real time and that's critical infrastructure. So there needs to be a separate sandbox where you can go and do all these tests. That's what the drone testing sites are about. So I hope I've given you that overview that tells you how we are working towards that vision, right? Because strategy drives tactics. Otherwise, you're just scrambling around in the dark. Eventually, we want to make every part of this system ecosystem enabled, everything from the aircraft to the places where you certify the aircraft to the human talent that needs to operate the aircraft. Clearly, there are some parts of our business that are more bigger contributor to revenue than others, but we believe that entire ecosystem has to develop in order for the industry to thrive. Thank you.
Thank you, Mr. Yong. I think that gives a holistic perspective of you going from an end-to-end service and ensuring that all aspects and components that go into manufacturing of a drone, right, from testing to even ensuring you're providing services for drone pilots to get their licenses. I think that's great to know how Singapore is kind of leading the way, and you're also leading the way with Garuda Robotics. I think over to Mr. Gupta, sir. Podrons has kind of, been commissioned to provide first mile, last mile logistics and commercial spaces. So you entering also into the drone space. So could you provide more details about the work that you do and the drone vertical under Podrons and your vision and the work that goes behind it?
First of all, thank you to PIC for inviting me. Thank you, Anish. Thank you, Ambassador Bambawale and Prafulji for referring me. Honored to be here. Some great talent in the audience as well as here on stage. So, in a lighter vein, I built a drone about half a century ago. Okay, when I was a child, I created this drone out of a carbon fibrous material. and it was propelled by a latent tensile potential energy system. Okay, I'm talking about balsa wood airplanes. Okay, with a rubber band to propel it. Okay, joking a little. Okay, so the most recent drone that I built had 4 propellers, motors, but most importantly, I mean, in that sense, it's not so different just in shape. But the big difference was that it had a full computer on board. It had 1 GB of memory, it had an ARM chip, and so on. Okay, and I/O ports, obviously. Okay, so I just wanted to make that point that a drone is not just some flying object. Okay, a drone, and that's why I've sort of, again, I'm being academic and pedantic here, but I don't even call them drones anymore. I call them UAVs, and by UAVs I mean unmanned and autonomous vehicles. He mentioned unmanned. Okay, that's important. So, and by the way, a little segue here into plug for our association. We've created an association. Some people here who support that are here. It's the Unmanned and Autonomous Vehicle Association of India, uavai.org. It's a non-profit. Please do look it up. Please do join us and participate. The idea behind UAVI is to actually spread the word about drones, how useful they are, make them more accepted, and also to create an environment, to create a network, to create the ecosystem of people supporting each other in this space, in the UAV space. Okay. So coming back to this UAVs, my interest in these unmanned and autonomous vehicles is in the field of logistics. So we are in the space of last mile logistics, and we are essentially a technology provider. Although we do some of the services ourselves, we are hoping to sort of franchise it more broadly. But like I said, one of in logistics our interest is in logistics. One of the big problems there in logistics is the delivery of packages to a specific location. Now, using GPS, which is what most UAVs do right now, is not accurate enough for proper delivery, because GPS is average of 7 meters accuracy. It's improved now, of course. There are other technologies involved, and also there's issues with when you have heights. So this whole vision of drones delivering to somebody's balcony or into the window is not going to happen simply using your ordinary, run-of-the-mill GPS. So we have some technology in that area. I have some patents that actually deal with precision delivery. So we can position a drone with theoretically 1 millimeter accuracy, although we haven't achieved that yet, but it's possible to do. And essentially it does that by using image recognition, by using image analysis, pattern recognition, and things like that. So that's sort of what we do in the drone space. And we are very clear that drones will replace some human delivery people in the delivery space, but it will be in the literal last mile. Okay, it will not be in the middle mile. It will not be, you won't, for example, be able to get your favorite pastry or biscuits from Kayani delivered to Baner. But you will be able to get something delivered if it's less than half a kilometer radius. And I won't go into all the details on how that thinking has happened, but there are certain technological issues there, as well as certain law and order, business issues, policy issues, which we can talk about in more detail later.
Thank you, Mr. Gupta. I think the logistics space is, again, one major application for the drones, and a lot of startups are also looking on how to solving the last mile delivery, and great that you are pioneering that effort as well. Over to Mr. Jha. I think IdeaForge has long been a pioneer and kind of like a market leader when it comes to the Indian drone sector. And with your extensive experience witnessing this growth and also seeing the revolution, so what are the key developments and that has happened over the past years that has led for IdeaForge being what it is today?
Well, first of all, thank you very much for having me here. IdeaForge is a deep tech company, started somewhere in 2007 by three IIT graduates, IIT Mumbai. Ankit Mehta, who was supposed to be here, and I'm representing IdeaForge today. It started with eVTOL UAVs, and now it has different sets of UAVs in its portfolio, starting from 2 kg range of MTOW to the 7 kg range. It is located at Mumbai, both Design and Development Center and also the manufacturing plant. Well, it's as you know, it's a #1 ranked in India, #5 in the world, and last year it was also put on the NSE. Lots of accomplishments since 2007, and looking at all these technologies, what it has evolved by itself. Looking at from the manufacturing in-house, sourcing from our supplier network, etc. So it has come quite a long way until now. Under the product roadmap, other than the VTOL and hybrid system, what we already have in offer, we have a well-stable roadmap for having a tactical UAV in the range. So essentially, when you look at today's, we are maximum up to 7 kg MTOW range. And what we are aiming right now, or what we are working on, is at least 10 times, all of weight from there. So lots of complexities, lots of challenges. And not only they are taking from the previous session, wherein we were talking about road transportation, logistics, etc. So that is in our roadmap as well on the middle mile logistic, and for sure the future of that would be mobility. And if you look at carefully, the challenges in logistics are way more than what we can envisage today or what we can imagine today. So high altitude, transportation for the goods, whether it is for defense forces or for civilian applications, the challenges are quite high. So that has been the journey until 2024. Beyond all that, IdeaForge is also a great place to work, recognized recent past. So, yeah.
Thank you, Mr. Jha. I think when you're talking about the challenges, I think any technology that comes into place has that phase where challenges are there, and then you're developing the technologies to ensure that you're reaching a place where you're providing safe means of technology. Just continuing on the technology aspect as well, I think, Mr. Yong, your expertise lies across various sectors from agriculture, emergency services, security. And as the drone industry continues to evolve, we see more and more innovation applications coming into the space. So could you highlight those key technological advancements that you see have kind of put this industry and put this sector on the map, and also seeing, in the recent years, just touching upon, again, what are those advancements specifically within the Singapore, Malaysia region that you spoke about? You mentioned some of them in your opening remarks, but if you could just dive a little more deeper into those aspects.
Right, so let me try to talk a little bit about some of the key tech advances that have, like you said, brought drones to where they are today. Some of the constraints we're facing, right? We're always looking for solutions. So if anyone here has solutions to these difficult problems, let us know, because this will be the next 10 years of development. So how do we get to the point where you could buy a drone, and even my grandmother can say, yeah, my grandson works on drones, and she can talk about that, for $3,000 from a store. One of the big advances that we actually got to ride on was the development of these guys, right? As you mentioned, today every unmanned aerial vehicle is stuffed full of chips. So a bit like the automotive industry, right? We are stuffed full of chips, and we benefited from the fact that you could now buy chips for a few dollars that 20 years ago were 100 or 1,000 times that price. I remember when I was an engineering student, I paid $250 US as a freshman to get a kit. It was compulsory for my first semester course. And this was an accelerometer, so it tells you which way you're tilting, right? And this allows you to move your phone all over the place, and it knows exactly where you're pointing. So back then, it was $250 US. They told us each group of 2 shares 1, because we don't have that much supply. Today, each of those chips is 20 cents. And they are completely commoditized. So that's the kind of development in the space of just 20 years that's brought us to this point, where we're able to buy something off the shelf for $500, and you have all the computing power available in this chip that tells you, read the GPS, tell us where we are, figure out which way I'm tilted, figure out how to control 4 motors, and adjust the speed so that even if wind is blowing, you can tilt the right amount to balance it. And you can do all this so stably that any camera that you put on it is going to correct itself and not look as though it's shaking. That is, if you look back at the history of the development, a absolutely stunning capability. Right? The second thing is actually connectivity. And if we were having this panel 5 years ago, it'd be a very different conversation, because I'd be explaining to people why connected drones are the future. Today, they are kind of standard, right? But 5 years ago, we were telling people, look, how long do you think it's going to be viable for you to have drones flying with a pilot standing 50 meters away? What is the point? Imagine if you're a security guard. Somebody's breaking in. So you have to walk with the drone and use it to see who is this person who's trying to break in. Is it a dog, a rabbit, a cat, or an actual intruder? Doesn't make sense, right? So there's this concept of beyond visual line of sight. When the pilot can no longer see the drone, that's when it's the worst for the regulators. It's the most scary, but that's also when the drones actually become useful. So BV laws is the next big push, and we can talk about the regulatory framework that's coming up. Right? So these 2 things, connectivity. Now if I go to any city, chances are I will be able to get 5G networks, but at the very least I will have 4G. Now, we started off doing in 2016 3G connectivity on our drones. So we could do slideshows, every 3 seconds a picture comes through on the screen. Then in 2018 we started doing 4G. We could do 720p streaming. Now, we can do 4K live video streaming over a 5G network. And I'm sad we couldn't do this today, but this past week, my team was in Malaysia, in Kuala Lumpur, at an offshore technology conference. And they were demonstrating 3 times a day, flying a drone from KL. The command center is in KL, the drone's in Singapore. We're flying over the internet, over a fully encrypted network, streaming live 4K video back to the command center. 5 years ago, nobody believes me. Today, they say, that's great. Now what more can you do? So that's how quickly things change, right? So moving forward, what else is going to come? I want to tell you about the 3 constraints. Number 1, autonomy. Number 2, energy. Number 3, safety. Now, let's start with autonomy. You have to get to the point where drones are able to take care of themselves. So this is a bit like the level 1 to 5 self-driving car problem that we heard earlier on. Once the drones are far away from you, the pilot can't see it, the drones have to take care of themselves if something goes wrong in between. So that's a big problem that needs to be solved. Today we've got a full graphics card on board the drones, and that's able to do all sorts of computer vision, fancy AI stuff, so that the drone can take care of itself, even if that link is lost. So all of this is important. One day you need to be able to press a button and just assume the drone is going to be safe, and it will get work done. Number 2, energy. So today everything's based on batteries, even though the military drone systems, the unmanned aerial vehicles, those usually run on gasoline. Now, why is this important? I want to give you some real numbers. The energy density of gasoline is about 50 millijoules per kilogram. The energy density of a lithium-ion battery is about 0.5 megajoules per kilogram. So it's a factor of 100. All right? So we just cannot keep up. That's why we can't do things like deliver for long distances based on battery. So if you have a solution for that, let us know. That would be awesome as well. And then final thing is safety. So I want to go back to then the manned aviation. Why is it that we are able to get on a plane and feel safe? Imagine an Airbus aircraft. So you've got 5 computers on board, and 5 computers all voting at any time to say, when you push the stick this way, which control surfaces should move. They all vote because sometimes computers make mistakes and there's safety in numbers. How do you make this safer? 5 computers, 3 of them were built in one facility, the other 2 were built in the other facility. Of those three, two were designed by one team in Toulouse, the other one was designed by a team somewhere in the UK. So there is multiple levels of safety and redundancy. How can we do that on a drone? An Airbus A350 costs 300 million US dollars. An ATR-72 turboprop plane costs 30 million US dollars. Our mid-sized drones cost 30,000 US dollars. An off-the-shelf commercial hobbyist drone costs 3,000 US dollars. So we have to find some way to build those safety and redundancy systems into something that costs 1,000 times less. These are the three big challenges. It's coming, but what I can say is that around the world, the environments are opening up so that all these developments can happen. The technologies are being driven by students coming out of the universities who are being told this is the future. So there are people being trained in AI, there are people being trained in computer science and engineering, and all of different technologies that ultimately are needed to build the next 10 years of developments in our sector. It's going to be super exciting.
I think, thanks, Mr. Young. I think what you said of looking back 5 years and seeing where we are today, I think the three constraints that you're mentioning today, hopefully we don't have to wait the 5 years, but hopefully sooner we're able to find a solution for that. And I'm sure, given how technology is advancing, we'll be able to kind of see that. I think I'll just move over to Mr. Jha. A similar question, sir, I mean, from an Indian context. Now we're seeing India wanting to be this major global drone manufacturing hub by 2030. We're having projections of the market being about close to $24 billion. Given that context, again, what are those key technological advancements that has allowed, say, even the Indian drone market to even project itself to that number? And what is kind of IdeaForge's place in that space? Yeah.
Well, first of all, I would like to change the word drone towards UAS or UAV. I took from Mr. Gupte to make it more gender neutral. I would say uncrewed aircraft vehicle now, not unmanned. So I would like to replace that. And if you look at our philosophy from IdeaForge, we have three major drivers during this UAV development. One is reliability, which also links to what Mr. Young mentioned about safety, is a part of reliability. Performance, needless to be said, and autonomy. So, and these are our three mantras during this whole course of UAV development. And when you take care of these, you meet total cost of ownership for the customers who are driving or you are flying with your UAV. If you look the technology advancements, it starts from the airway structure or airframe itself. So when I compare UAV, although the MTOW or the weight, maximum takeoff weight we typically call in case of UAVs, you deal 5 kg, 10 kg, 20 kg. When I compare with my prior experience on some Indian development indigenous missiles of 6 tons or 5 tons, it looks very simple or very lighter compared to that, of course. However, when you go deep inside, I would not call from the technology complexity perspective even a micron below that. So because it has every system, and some of our colleagues already mentioned. So therefore, looking at airframe itself, today we typically work with FRP composites or the magnesium alloys or aluminum alloys for weight efficient structures. Moving forward, how I look at it, it is not going to stay only up to magnesium or aluminum or typical FRPs, but it's going to be more of nano composites. So if you look at carbon fiber reinforced plastics, some graphene induced or some other nanoparticle induced to make it lighter, so weight efficient. And each gram of weight is very important. They're very critical because you have to power by the energy storage systems, maybe battery in this case. So I see that high performance material innovations are part of UAV design and development moving forward, and we cannot ignore that for sure. On the payload, Mr. Young mentioned already about, so the resolution of camera, the performance of recorders are improving day by day. And as the technology are improving on that aspect, it is getting horizontally cascaded and implemented for UAV as well, needless to be said. I also see that in future, we will have provision for multiple type of payloads, which we do not have today. So when we look this whole UAV ecosystem as a whole, we started with lots of restrictions. So when I read the subject line of the theme today, revolutionizing or revolution, I say revolution has not yet kicked off in this front. It is yet to happen. So we are at a very, very elementary level on that. Even if I can claim that Idea Force has done a lot, and likewise many other globally industries have done, but those are at the very elementary level right now. If you look at the energy sources, again coming back, battery is not only limited, the energy density is well explained by Mr. Yang a few minutes before. So is fuel cell alternative? Are the solar power alternative? Are other sources of energies alternative? Because what is very important here, moving forward, that the endurance and range. So we have that struggle. You cannot keep more than 50% as your power source in a UAV. Then you do not meet the objective for which you are designing the UAV. And therefore, the weight budgeting is important, and hence the source of power is equally important. Likewise, if you go to ground communication system and related devices, there as well lots of researches are ongoing in electronic side, both embedded and power electronics. And beyond that, the smart and intelligent software systems. So these are certain areas which I foresee that it's going to go in next 3 to 5 years' time, not limited to maybe.
I think, thank you, Mr. Jha. I think that also puts into perspective of how these technological challenges that manufacturers are also overcoming, and also ensuring that the market continues to grow. Overcoming all these challenges. I think moving to Mr. Gupta here. So we're looking at AI and machine learning also in drone technology. I think given that you're in the logistics space, I think that kind of transforms a lot of things within the drone sector. Given these innovations that are coming into place, how do you see this technology play into what you do? Yes.
So we at Podrons, we take a very, very narrow focused view of the technology that we have to work on. I know very little about batteries, nor does people in our team. We leave that to others. In fact, after building the first couple of drones or the prototypes, we decided not to get into the manufacturing, the hardware part of the drones, pretty much. We focused on exactly what you're talking about, which is the machine learning or AI. And I mean, if I call it AI, it's a very crude form of AI, okay, right now at least. But it's essentially, like I said earlier, pattern recognition, image recognition. And if I can take a moment to explain, it's really, I find it interesting. I don't know if you will, but the technology is very simple. You take your camera, your phone camera, you can try it right now. Just position it over some rectangular object, okay? If it isn't correctly positioned, if this piece of paper, for example, is a little further, what will you do? You'll move the phone a little bit, okay? This is your sort of just rational thinking. And that's essentially what our technology does, okay? We use image recognition, and it can be any image. It can be a QR code. It can be something that a picture of your child that you sent a drone, and you put that picture on the table, and the drone can come and see it and position itself there. So that is the key thing that we're working on. And obviously, we'll get more sophisticated and use more machine learning and more AI in that. And that is how we are going to really transform that last inch, you can say, of delivery.
I think just to follow up on that, and probably just moving into our next segment of looking at the market growth and potential, even where you're talking about fixing that essential last piece of the puzzle in looking at this thing. So what are the kind of economic implications of the widespread adoption, say specifically even within the logistics sector? And could you also elaborate a little more on the value chain that it creates?
So we are going to be disrupting the delivery people. It's not, not being hard-hearted or anything, but really, I feel that they shouldn't be out there in the dust and the heat and the cold and in the rain doing deliveries, and machines should be doing it, right? And those same people, I feel, and this is a policy issue, those same people should then get into the drone delivery part. Now, this may be a little unpopular statement here, so please forgive me, but I don't think we should be training drone pilots, because what we want really is autonomous drones. This is where we are heading. We don't want somebody sitting there guiding the drone, because actually, even a good drone pilot, the machine can do a much better job, actually. And the more it learns, it can do an even better job of maneuvering to the right locations. So I think, as a policy issue, I think, if at all the government has some say in the matter or wants to do anything, instead of encouraging drone pilots, you want to be encouraging drone engineers who can build these, who can experiment with UAVs and the artificial intelligence built into that, and even into the battery and the aerodynamics. And maybe there can be it can be something even like an ITI just for drones, or a specialty within ITI for drones. That is, I think, where the policy should be heading. And the economic impact of that will be huge, because, ultimately, and this is an unfortunate thing in India, is that we rely too much on the labor market, okay? And that keeps people poor. And that limits the kind of economic impact that can happen in India. And the more we embrace technology solutions and, and train our workforce to be technologically skilled rather than manually skilled, I think, it'll be a big boost economically. It'll be a very powerful force, I think, in the Indian economy.
I think rightly said as well. I mean, there are policy challenges that needs to be kind of looked into, and ensuring that we're creating a conducive environment as well. I'll move to Mr. Yong as well. I mean, Singapore has been kind of forthcoming in ensuring that regulations are, of course, keeping the safety in mind, but also ensuring that it is advocating and advancing technology, specifically in the drone sector. In that context, how do these regulatory frameworks and government policies influence the development and adoption of drone technologies? And what do stakeholders like you, who are in the manufacturing and who are also from an end-to-end manufacturing perspective, kind of play in this whole regulatory landscape?
So let me answer that with a couple of stories first. At the air show in 2018, I think, there was a panel, someone from representing the Rwanda side, and then Hong Kong and Singapore and a couple of other countries, right? And Rwanda is actually well known for being pioneers in the use of drones for blood delivery. And it's got a massive life-changing, life-saving impact, because you don't need individual clinics to store refrigerated blood supplies anymore. You need it? Okay. A drone's going to get it to you in half an hour. So an hour before the surgery happens, if somebody came in an ambulance, you can get fresh blood supplies. So the CAA representative from Rwanda was talking about this and saying, it is incumbent on us as civil servants to serve the people by opening up this usage of the airspace, because it literally saves lives. Now then, next it was the representative from Hong Kong who said, we have this situation. This is the airspace in Hong Kong. It's much smaller than Rwanda. And every single inch of that airspace has 5 people claiming the use of it. So in Singapore, we are closer to Hong Kong than Rwanda, right? And this just to illustrate what it means when drones as an industry have to grow up. Now, it's quite one thing when you've got people building drones in a school, people using drones for videography to take photos, to actually saying we want this to be widespread and doing deliveries over a city, right? You are in aviation. Now, what does this mindset actually mean? 5 years ago in Europe, so EASA, the EU Aviation Safety Agency, they were going through this debate. Is a drone a fridge or an airplane? And you think about that. So what they were asking is, who should regulate drones? Are they consumer devices that are regulated like fridges? Or are they aircraft that are regulated by EASA? We all know the answer, right? So you are a part of aviation. So eventually, right, you cannot escape this. You will be held to all the standards that we take for granted, that I took for granted when I got on a plane in Singapore and landed in Pune. How do we get there? And that's critical. So I think there are many in the drone industry who are still trying to push this away. They're not willing to grow up and say, yes, we get the sector that we're in. And so today, I want you to think about, all of you, how much do I pay every year in licenses and certification fees compared to, say, how much I pay for rent? I'm not going to tell the answer, but it's scary, all right? But it's a good thing because every license gives me clarity. It tells me what I can and cannot do. Now in Singapore, when we apply to the Civil Aviation Authority of Singapore. I have an annual operator license I pay for. I have individual permits that I pay for each flight. Each flight can be applied for no bigger than 2 kilometers in radius. I have height limitations. I have height limitations on weekdays and weekends. It's great, right? And when I apply for a permit with the Civil Aviation Authority of Singapore, they go and circle around to 13 other agencies to get sign-off from the Law Ministry, from the Home Affairs Ministry, all these people. That is, if I wanted to be any more regulated, I could build blockchain into my systems, and then the finance side comes and regulates me. And I have a drone insurance platform, so I'm kind of already tied to the finance regulations, right? So all these are critical if we are one day going to fly side by side with manned aircraft in what we call an integrated national airspace, because until we get there, the manned aviation community does not take drones seriously. The manned aviation community says drones are unsafe, and the true economic potential of uncrewed aerial systems, whatever form and shape they take, whether they're piloted or whether they're completely autonomous, will not be fully realized. And that's something which is also unpopular. There are many people who say, let's just push whatever we can. But I think we need to step up and say, look, let's work with the regulators. So that's what I've been doing for the last 10 years. I worked with regulators. We work with them to do tracking of drones, even though the community then says, you are basically the regulator. We're not. We're a private company. But we believe that regulations are important, and we will do everything it needs to prove that our devices, our aircraft, are safe to fly side by side with a Boeing aircraft, with an Airbus aircraft, and that is the standard that we hold ourselves to.
I think an interesting point that you brought about. Yes.
Maybe I would like to add few.
Yes, Mr. Jha, please.
Into it. So we should look at it from drone as a product and drone as a service both. And when you take the drone, or I would like to use UAS again, or UAV. So when you take it beyond surveillance purposes, so you are using for traffic monitoring, disaster management, you know, the minor logistics, and also the enterprise applications as well. The regulations and certification requirements play a very vital role there. Today's ecosystem is not as developed as we would like it to be. There are agencies, we have government agencies, DGCA, through Quality Council India, then we have certification bodies, and then comes the manufacturer. So it's the queue is longer. There are challenges we have from the ecosystem itself today, and DGCA has its own challenges under Ministry of Civil Aviation. At the same time, some limitations what we have, for example, 6 months lead time for getting regulation or type certification before you make the UAV deployable and you can use it. That's something which is a challenge right now, and that needs answer, how to expedite it. And when I go closer with MOCA or DGCI, I understand what challenges they have right now. Second, one manufacturer can apply or can work on only single type certification. Imagine you have 10 product lines. So it takes 5 years for you to have type certification done. And why I was trying to link with this is with services as well, because for surveillance, it goes with Indian Armed Forces or respective armed forces around the world, wherein you do not necessarily need type certification, but to make your UAV airworthy so that you can officially use it, you have to have type certification. And there are challenges, and there has to be right regulations because it plays with safety as well. It's the same airspace where we have civilian aircrafts flying, helicopters are flying, and then our flying altitudes are falling at times with them. So, yeah.
I think, yes, sir.
I have a question for my fellow panelists, and perhaps you. Do you see, because you mentioned, both of you, that drones flying next to Boeing aircraft, manned aircraft, do you see them actually next to each other, or do you see separate sort of streams, one for certain kind of drone, one for a different kind of drone than the manned aircraft? What is your vision in this? So do you see them all sharing one airspace, like drones to Boeing aircraft? Or do you see, layers or streams, and where would they be? Do those streams follow the roads?
Well, again, it depends on what kind of UAV we are talking about. So starting from nano to micro to a small, mini, medium, or high class of drone. So depending on that, your flying altitude is. Typically, the government regulation limits you up to 200 meters right now, above ground level. And that's not the operating range for helicopter or aircraft. So therefore, in the ranges of UAVs what we have today, we are leaving their aerospace. But future, as we were talking about 5 to 10 years, when you see you have middle mile logistics or the mobility services added, also tactical added, which would have to run at higher altitude, which may fall with the typical defense helicopter applications or civilian applications as well. So there has to be a proper airspace designated, and that has to be certified, no? And a lot of work are supposed to be done at the moment.
I think we look at both the performance and also, again, the ecosystem, right? So we all know that airliners operate at a certain altitude, several tens of kilometers up. Helicopters usually 500 to 800 meters, thereabouts. And then where do drones go? Today, drones go 200 meters and below. But think about it this way, from the aviation regulator perspective, they always give you the worst case. What if everything fails? What if everything goes wrong? Even if you have the drones limited to, say, 80 to 200 meters, if everything goes wrong, if they sense that they're actually at 20 meters, but they're actually at 80, because the chip has gone wrong, then this thing is going to start climbing up, right? It climbs up into the place where helicopters are. What if the chip is even more wrong? It starts climbing up into the part of airspace where your 747 is, 777 is taking off, right? So that's the way regulators think. And I think it is incumbent on us as trailblazers in the sector to say, look, we understand your worst case concerns, and then come up with mitigation strategies. You cannot work with a regulator if you have a very rosy picture of the world and you're always telling them this is the best case, because regulators think about the worst case, and that is their job. They are doing exactly what we pay them for. So I think, whether or not it's going to be segregated airspace, whether or not everybody will be able to fly, whether there's some intersection, truthfully, I don't know, because the market is yet to work itself out. We're all very hyped about drones, but people forget we're only about 10 to 15 years into this commercial drone revolution. And it's impossible to predict. My track record, I won't tell you specifically, my track record on predicting how the market will go has been 50-50 at best. So I think I will stop here.
Thank you, Mr. Young. But I think that in the interest of time, I think it's very interesting how to see the whole UAV segment with the larger commercial aviation space as well. And given that we have a common regulator here in India as well, I think that's very kind of an important aspect to kind of ponder upon and not look at the whole UAE segment in silos. I think just in the interest of time, I'll open it up to the audience if there are any questions. We have 5 minutes.
If you allow, I would like to add one another aspect which was spelled out during initial session, that a production link incentive topic, that's very important for us. So, so today, if you look at overall policies and schemes from government, so one is drone rules 2021, it came up, that opened up lots of avenues for UAV manufacturers. The production link incentive has been another one, which has been very encouraging for the industries. Maybe a few words about that. If you have more than 40% value addition inside your manufacturing facility, you are eligible for that. What you are eligible for is that percentage, 20% value comes from this government support of PLI. What we should also do in addition to it from the regulation perspective is giving weightage to design and innovation. So one is producing, and we are doing it, Atmanirbhar Bharat, Make in India, whichever scheme we call about, and that's very positive development, like I said. But we have to have weightage for design innovation. So for example, if you are working on research and development of it to bring it to the next level, so there should be some encouragement from the government scheme as well, or else you would, for the sake of getting under PLI, you produce 40% by having value addition and bring everything from somewhere which is available. Of course, we should not reinvent the wheel as Mr. Yong was mentioning, but at the same time, having technology, innovation and patent developed inside this ecosystem is very, very important, and that is something which I wanted to bring in.
Thank you, sir. I think just a quick round of questions with the audience. I think we'll just take one.
So I have a question anyone can pick. And I was not daring to ask this after learning a lot of regulatory challenges that you're facing. Will drones always be uncrewed? Will those ever be used for applications where there will be people in the drone, like ambulance or some of those things? Will that R&D happens? Yeah.
Yes. Sir, I think we'll take the questions together. Yes, sir, please.
I have a question regarding the energy source for drones. One is probably a little nearer us. What is the status of using hydrogen for drones? That's one. Second, I'm sure you've come across a news item which came about 2 years back where a company in New Zealand has developed methods of transmitting electricity wirelessly over large distances. Is there a possibility in the future of having towers which will generate wireless electricity which can be used for drones, which do not consume too much power?
Yes, I think one final question and then we'll just pass it on to the panelists.
So in the Russia-Ukraine war, the Russians and of course the Ukrainians have been jamming drones. I don't know enough about this, so I'm very curious. What are the risks of sabotage to drones when it comes to civilian use?
Yes, I think if you could answer the energy aspect, since you brought up that also as a challenge, and then we can have you answer the flying cars.
Yeah, so the first one I would like to take, when you say, does it necessarily need to be uncrewed? So when we say uncrewed, it's a pilotless, or else in the middle mile logistics or mobility, when you see, there would be human aspects as well in it. So, so the first step is logistics, wherein you carry what you want to carry. For example, when a helicopter pilot from Indian Army takes some logistics from here to high altitude of let's say 5,000 meter AMSL, so above mean sea level, it can carry 20-25 kilogram of logistics. That's very little. which you can avoid having a pilot's weight at least putting into the logistics weight. So then you can carry immediately to 100 kilograms. So uncrewed means pilotless. It can. So in place of payload, it's a human. But we are not yet there. So around the world, there are companies like Volocopter in Germany, who have started doing this as a demonstration, technology demonstration. But as you know, there are a lot of safety regulations which have to go into, and the world is just step by step moving towards that.
So if I might just add to that, we are very far, in my opinion, we are very far from uncrewed passenger vehicles in the air, because we haven't yet even got uncrewed passenger vehicles on the ground. And this is happening in the US, where Tesla has been banned from conducting these. So I think we're a ways away from that.
We'll just close with the energy and the security answer, and then yes.
Right. So energy, I think the short answer is I have been pitched like every month. A startup or somebody will come to tell me wireless transmission of energy. When you're hovering over the power lines, can you tap from the power lines? Hydrogen fuel cells. I think we are all open. It's all about ultimately scale. So it's no use having one demonstration system that you can use to showcase, because our interest is how do you put 1,000, 5,000 of these machines out in the plantations of Malaysia where we operate so that it can actually be commercialized, right? So I think that to me is the fundamental question. Can you commercialize it? Until the point when you can produce from your factory whatever I demand, it is still R&D and it's on the roadmap. I think that's a short answer. The second part is security, so absolutely. So I think we've all talked about this in various forms. Having more AI on board means that you are more and more likely to be able to have the drone work well. Now, I want to say the number one reason, it's a half joke only, the number one reason you still have drone pilots, if a drone crashes into some high-rise building in downtown Mumbai, who's going to go to jail? Somebody has to go to jail. Somebody has to stand in front of the judge and say, sir, I'm sorry, it's my fault. Please be lenient. That is fundamentally what the drone pilot is about today.
Yeah, I think in the interest of time, thank you all. It's been a great session. We've covered a vast array of topics, from technology to potential growth to also addressing if flying cars are a possibility. I thank each one of you, and thank you once again, and hopefully this has been a great conversation and great insights for the audience as well. Thank you.
Please give them a huge round of applause, ladies and gentlemen. Could I invite Ambassador Bambavale up onto the stage to offer a small token of appreciation to our panelists and our chair?